Our today's lesson is on segment, arc addition, and arc length. We'll start with segment addition postulate. If a point B lies on a segment AC, then the length of segment AB plus a segment BC is equal to the segment AC. One way to say it is the sum of the parts is going to equal the whole. For example, segment AB has a length of X, and segment BC has a length of Y. So when you add the two together, X plus Y must equal the length of AC in this case. All right, let's look at some problems involving that. Show the length of XY in the figure. Find the length of XY in the figure. So we know that the whole length is XZ, from endpoint to endpoint. So we know that XZ, the whole segment, is equal to the sum of the parts. Well, the parts is XY plus YZ. So we know that XZ has a length of 17. We know that XY has a length of X. We know the length of YZ has a length of 11. So you're left with this equation, 17 equals X plus 11. And if you solve this, you get X to be 6, which means that the length of XY must be 6. And it's always good to check. 6 plus 11 has to be 17. All right, find the length of the segment AC in the figure. All right, we know that AC, according to the segment postulate, has to equal the sum of its parts. The parts is AB, and it has to be equal to the sum of AB plus BC. We know AB has a length of 2x. We know BC has a length of 2. And they tell us AC is 7 plus x. All right, so what you're going to do is you're going to solve that equation. I'm going to put it down here. So I can subtract x to both sides, right? So I get 7 equals x plus 2. And if I subtract 2 to both sides, I get x equals 5. So since we know x is 5, they want to know the length of AC. So we know the length of AC is 7 plus x. So AC has to equal 7 plus 5, which tells us that AC has to be 12. All right, we're going to look at arc addition postulate, which is very similar to segment addition postulate, except now we're dealing with a circle. The measurement of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So, for example, you have arc XYZ. So we're looking at this whole arc here. And we're saying that that has to be the sum of these two arcs. We have XY and YZ. You add those two arcs up and you're going to get the sum of the whole arc. This whole arc is going to equal that. All right, in this case, we're going to find the measurement of arc LHI in circle M. And we're given that measurement of angle HMI, this angle here, is 32 degrees. And we're given that this angle here, IMJ, is 90 degrees. And from a previous lesson, we know that since these are central angles, that the arc has to be the same measure. So we know that this is 90 degrees. And this arc here has to be 32 degrees. And what we want to do is this. According to the arc postulate, this arc here, LHI, has to equal the sum of the measurement of arc HL plus the measurement of arc HI. But the problem is we don't know what HL is. We got to figure out what this measurement is. We know this is 32 degrees. And the thing that helps us is that we know this is a diameter here, because it's a chord that goes through the center of the circle. And we know that has a measurement of 180 degrees. So that means this distance from here to here is 180 degrees. So what we're going to do is we're going to add these two measures up, 32 plus 90. So you should get 122. And what you want to do in order to get what this angle is, you have to subtract 122 from 180. And when you do that, you're going to get 58 degrees, which means that this is 58. So you can put it into the formula. So we know this is 58. We were given that this is 32. And if you add that up, you're going to get a sum of 90. So that's how that works. So that arc has to be 90 degrees. All right, let's talk about arc length. The ratio of the length of an arc, I, to the circumference of the circle is equal to the ratio of the degree measure of the arc to 360. So what that means is this. So this arc, I, is to the circumference, that's why I have 2 pi r, is equal to this angle x to 360. So the measure of the whole of the angles of all the circles. And you can use this to figure out the arc length. All right, so for example, find the length of arc DA. We want to know what this length is here. This time you want the length. We're not asking for the measurements. We're asking for the actual length of this arc. So the radius is 4.5 centimeters. So from here to here is 4.5. And what you're going to do is set up the proportion. So we have L is equal to the circumference. And we know that this measure of the central angle is 40 degrees to 360. But you first have to get the circumference in order to solve this problem. So let's do that. We know the circumference is 2 pi r. So you get 2 times, we're going to use 3.14 as an approximation for pi. Our radius is 4.5. So you want to multiply that all together. When you do that, you're going to get 28.26 approximately. All right, so now that we know the circumference is that, it's 28.26. We're going to set up the rest of the proportion. we're trying to figure out the arc length here. So the circumference is 28.26. We know that the central angle is 40 degrees. And you set it equal to the total angles of the circle is 360. So what you want to do is cross multiply. So that's 360 times L equals 40 times 28.26. And you're going to multiply and divide both sides by 360. So you should get L. When you do that, it's going to equal roughly about 3.14. Remember, this is in centimeters. Let's try one more. Find the length of DA, the arc of DA. That's this arc here, with the radius of 6 centimeters. So the radius is 6 centimeters. Again, the formula is the length is to the diameter, which is 2 pi r. And you have to take the central angle, in this case it's 28 degrees of that arc, and set it equal to 360, the total angles of the whole circle. Again, you have to get the circumference. So do that first. So 2 times 3.14 times the radius. The radius is 6. And if you do that, you should get 37.68 approximately. All right, so we know that the circumference is 37.68. Now you can use it in your proportion. So the arc length is to the circumference, 37.68. Then you put the central angle is to 360. And you cross multiply it like the previous problem. 360 times L equals 28 times 37.68. And you're going to divide all this by 360. When you do that, the length is going to approximately equal 15.9 centimeters. All right, this concludes the lesson for today.